So let's start this project by solving this kind of question. This kind of question is actually based on finding unknown numbers of binary operation. So we have to solve this one. How do I solve it? Let's call the question out. They say 100 base x equals 40 base 5. That's very easy though. How do I solve this? Let's convert everything here. Let's convert it back to base 10. Since base 10 is always the origin of or any other base, since this is number base, so let's convert it back to base 10. Don't forget 0, 1, 2, 0, 1. But without minding what I'm making this faster, these zeros they'll actually cancel out, or let's show it how it's going to be cancelled out. That will be the first value will be 1 times x raised to power 2 plus 0 times x raised to power 1 plus 0 times x raised to power 0 equals to 4 times 5, this 5, raised to power 1 plus 0 times 5 raised to power 0. So we have 1 times x squared, that's x squared. 0 times here, everything here is 0. 0 times this is 0. Then we have equals to 4 times 5. 5 raised to power 1 is 5. 5 times 4 is 20. Then plus 0 times 5. 5 raised to power 0 is 1. 1 times 0 is 0. So that's our left. We are left with x squared should be equals to 20. So from here, since we know that x squared equals to 20, we can say square root both sides as x equals to square root of 20. From here, we cannot stop here. This is solved. We can say x is then equals to square root of 4 times 5. So from here, I can say x is then equals to square root of 4 is 2 root 5. And that's the final answer for x in that part. Now let's go for number 1b.